Okay, so now we have this curve and it's defined implicitly because we don't know how y and x are related. We just have this like jumble of x's and y terms that come together to make this curve. Okay, and we want to write an equation of a tangent line to the curve at negative 2 comma 1. And part of this work's already done for us because we already know x1 and y1. It's negative 2 and 1. So we are going to write y minus y1 is 1 equals m times x minus negative 2 is going to end up being just x plus 2. So all we need to do is determine what m is at this point. And to do that, we're going to need to find dy dx because that'll tell us our slope depending on our y and our x values. So what we need to do is implicitly differentiate this curve. So we have the derivative of x squared is 2x plus the derivative of 2x is just 2 plus the derivative of y to the fourth is going to be 4y cubed times the derivative of y with respect to x, dy dx, plus 4 dy dx, and that's going to be equal to 0 because the derivative of 5 is 0. Okay. We need to isolate dy dx, so we're going to move the 2x and the 2 over to the other side. I think we've done this example actually in a previous lesson. 4y cubed dy dx plus 4 dy dx, and that's going to be equal to negative 2x minus 2 if we subtract the 2x and the 2 over to the other side. So then we factor out dy dx, get 4y cubed plus 4, and that's equal to negative 2x minus 2. Okay, divide the 4y cubed plus 4 over to the other side. Dy dx equals negative 2x minus 2 divided by 4y cubed plus 4. Okay, this is going to determine our slope at any x and y value we want, but specifically we're looking at x equals negative 2, y equals 1. So now we can just plug in those values. Dy dx equals negative 2 times negative 2 minus 2 over 4 times, I already forget why it's 1, right? 4 times 1 cubed plus 4, okay? So let's do a little simplification. Negative 2 times negative 2 is positive 4. And then here we have 4 times 1 cubed is also positive 4. So then this is going to be equal to 4 minus 2, which is 2, over 4 plus 4, which is 8. Okay, and 2/8 is obviously simplifies down to 1/4. So our slope is 1/4. So we can say y minus 1 equals 1/4 times x plus 2. And that is the equation of our tangent line. Now I want to go back and talk about dy dx for a second, because you see that this dy dx will tell us the slope no matter what x and y are. Like let's say x is 7 and y is 12. I'm going to plug in x equals 7 and y equals 12, and then that'll determine my slope at that time. But the thing is, 7 and 12 are not necessarily on the curve. What does it mean for a point to be on the curve? Well, we need to be able to plug in x and y and have this side equal 5, right? So if I plug in negative 2, I get negative 2 squared plus 2 times negative 2 plus y is 1 to the fourth, plus 4 times 1, right? So let's simplify. Negative 2 squared is positive 4. 2 times negative 2 is negative 4. Okay, plus 1 plus 4. Okay, well, what is this? 4 minus 4 is 0, and then 1 plus 4 equals 5. So overall, this equals 5. So the point negative 2 comma 1 is on the curve because when you plug in negative 2 and 1, this side ends up being equal to 5. But if you pick some other random point, it's not necessarily going to be on the curve. So once we know if a point is on the curve or not, like negative 2, then we can plug that into our dy dx and determine the slope at that point. So we plug in negative 2 and 1 and find out the slope is 2/8, which is 1/4. So now we have our equation of our tangent line. So if we look at the curve, it's kind of a weird looking curve, right? Not like one we've usually graphed. And we can see that at x equals negative 2, y equals 1, we have the equation of our tangent line here. And that is the line tangent to the curve at x equals negative 2, y equals 1. I have some other stuff on here because I used this from a different lesson, but we're just focusing on this equation of the tangent line here and focusing on what the curve looks like. And you can also see, by the way, that if you type in a curve like this into Desmos, it'll show you what it looks like. So you can feel free to mess around with that and see what kind of curves you can come up with. Okay, we're going to do one more example, and this is going to be a harder implicit differentiation problem. Okay, so first of all, write the equation of the line tangent to the curve at y equals 1. So I don't know what x is. So how can I fill in my equation of my tangent line if I only know y but not x? Okay, because y1 is equal to 1. Well, what I have to do is come up here and figure out what x is when y is 1. So I have x squared times 1 plus 4 times 1 cubed equals 4 plus 2x, right? So this is x squared plus 4 equals 4 plus 2x. So how am I going to solve for x? Well, let's subtract everything over to the other side. So what's 4 minus 4? Well, that's just 0. So I have x squared plus 4 minus 4 is 0. And then we're going to subtract that 2x over. And now on this side we just have 0. So then we have x times x minus 2 equals 0. And this is going to happen when x equals 0 or when x equals 2. So we actually are going to have two tangent lines potentially because we have two different x values that go with that y value. We could say x1 is 0 or x1 is 2. So that's what we're going to fill in one of those values for our x1. But what we need to do is also determine dy dx so we can determine the slope at the x and y values we end up with, right? So let's go ahead and erase this because we'll just rewrite this later so that we can differentiate right under the curve here, okay? So we have x squared times y. So that's a product, meaning that we will have to use the product rule when we differentiate. So we're going to take a derivative of the first function, x squared, leave the second function alone, plus x squared times the derivative of y with respect to x. That's what the derivative of y is. Plus, derivative of 4y cubed is 12y squared times dy dx. And then that's going to be equal to the derivative of 4 is 0, plus the derivative of 2x is just 2. Okay, so now we have to isolate our dy dx. So we'll move everything else over to the other side. So we have x squared dy dx plus 12y squared dy dx. And that's going to be equal to 2 minus 2xy. Okay, factor out dy dx gives us x squared plus 12y squared, and that's equal to 2 minus 2xy. And then now we're going to divide by x squared plus 12y squared on both sides. Dy dx equals 2 minus 2xy over x squared plus 12y squared. So this is our equation for, or this is how we determine our m value. Okay, so let's start with our points at x equals 2 and y equals 1, right? So we'll use this one first, 2 comma 1. Okay, so we have to plug in x equals 2 and y equals 1. So we get 2 minus 2 times 1 over 2 squared plus 12 times 1 squared. Okay, so we have 2 minus 4 over 4 plus 12, right? So that's going to be 2 minus 4 is negative 2 over 16, right? Which is going to be negative 1/8. So now we have to just write the equation of our tangent line. Y minus 1 equals negative 1/8 times x minus 2. And that is the equation of the tangent line at 2 comma 1. Okay, what if we do the point 0 comma 1? All right, well, we'd have to come back down here and plug in 0 instead of 2 for x. Okay, so I'm going to redo this now with a different x value. Okay, so we'll say 2 minus 2 times 0 times 1 over 0 squared plus 12 times 1 squared. Okay, so this is going to be 2 minus 0 over 0 plus 12. So then that's going to be 2 over 12, which obviously simplifies to 1 over 6. So now for our other tangent line, it's going to be y minus 1 equals 1 over 6 times x minus 0. We can just write like this, 1/6x. So then that is our equation of our tangent line at 0, 1. So if you're given only the y value, you have to plug in the y value to determine the x value. And then once you have x and y, you plug x and y into your dy dx that you determined to figure out your m value. All right, and that is it.